Hi guys, so for today what we're going to be doing is we are going to continue with multiplying our fractions. And what we're really going to focus on today is we're going to compare the size of the product to the size of our factors, what we are multiplying. So just kind of make sure that we're really paying attention to what we are doing to understand, the difference between the numbers, the size of those numbers and everything else, okay? So the first one it says is solve for the unknown. And this says to rewrite each phrase as a multiplication sentence. We'll go ahead and do that first. And then it says circle the scaling factor and then put a box around the number of meters. So that's pretty simple, because I know which one I'm going to put a box around is going to be the meters. The scaling factor is basically going to be that fraction of what I am going to be multiplying it by, or the number that I'm going to be multiplying it by, okay? So the first one, we've got 1/2 as long as. So when I hear as long as, I know I'm multiplying, and it's 8 meters. So I have 1/2 times 8 meters. And I'm not going to label 8 just because I don't want to label it quite yet. And I'm going to solve it in just a minute. But I want to circle the scaling factor. And the scaling factor is that 1/2. Because that's what I'm really looking at, is I only want to know it's half as long as. And then I'm going to put a box around the 8 because that 8 is my meters, is how long it is. So then when I go ahead and multiply this out, remember when I multiplied the whole number, this has like that little invisible 1 underneath, and I just multiply straight across. 1 times 8 is 8. 2 times 1 is 2. 8 divided by 2 is going to be 4, so your answer is 4 meters. Okay. This one's a little bit different because it's not necessarily, when I'm circling the scaling factor or circling the meters, it's not going to be a whole number or a fraction, because this one changes that now I've got 8 times as long as 1/2 of a meter. So I have 1/2 of a meter, but this is different because it's 8 times, oops, sorry guys, I shouldn't box that in. I think I'm getting used to just boxing things. I want to circle this because this is my scaling factor. It means that I'm doing that 8 times, okay? And then my box is going to be that 1/2 because it's going to be that 1/2 a meter. So it's that measurement. So now I can go ahead, remember, invisible 1. 8 times 1 is 8. 1 times 2 is 2. Then 8 divided by 2 is 4. So your answer is 4 meters. It's the same answer, but it's asking two different things. And that's the whole thing you guys need to remember, because first it was saying I have something, but it's only half as long as that. But then over here is I had a shorter piece and it's 8 times as much. Even though the answers are the same, guys, these are two totally different problems. So the next one, it says to draw a tape diagram to model this, so to be able to see this. So here is where my tape diagram is going to come in. And this is where I think you guys are really going to be able to see, okay, I see what the difference is. So I have half, okay, so remember I've got half, and what I have is my whole, or what I am measuring is that 8 meters, okay? So this is my half that I was looking at, okay? This is where it's going to be a little bit different, because what I need to do is it's 8 times as long. So what I'm going to do is I'm going to make 8 different sections. 1, 2, 3, 4, 5, 6, 7, 8. Because each of those 8 is a half. So that when I go ahead and look at this model, what this all equals, this would all equal 4. Okay? And the reason is right here. The scaling factor is less than 1. So the number of meters is decreased. Okay, so my scaling factor is less than 1. But over here, my scaling factor is greater than 1, so the number of meters is actually increased. All right? So this next one says to fill in the blank with a numerator or a denominator to make the sentence true. So what I need to do is I need this side of my equation to be less than 7. So I need to make this less than 7. So the thing is, what I do know is that, guys, if ever I have a number, a fraction, that has the same numerator, denominator, that equals the number 1. Okay, so when I think about this, this is what it equals to. It equals 1. So if I want this number to be less, because that's what it says, it's less than, I want to multiply this number less than 1, so I would multiply it less by 3/4 because that's less than 1, okay? Over here, I want this side to be greater than 15. Okay, so what I'm going to want to do is I want to make sure that if it's greater than 15, I want it to be greater than 1. And so when you think about this, you want it to be a mixed number. So I'm actually going to turn this into 7/5 because I can multiply 1 2/5 times 15, and I'm going to get greater than 15. So if I go ahead and multiply this out, let's just kind of check. I want to show you guys this. So I've got 5, 3, 7, 8, 9, 10. Okay, so 10/5 divided by 5. The answer is 25. So I just created this, and that's 25 is greater than 15, okay? Now this one I want to make sure that it's equal to. So when you want to make something equal to, guys, going back to this, I want to make it a 1. So how can I turn this something fifths into 1? Well, I would just turn it into 5, okay? Because I want it to be equal to. And I could also check my work here. So 3 times 5 is 15 divided by 5 is still going to give me that 3, okay? So looking at number 4, I've got these inequalities, and it says that I want to look at all the inequalities, and I want to choose a single fraction to write in all of those blanks to make the number sentence true, okay? So what I'm basically wanting to do is I'm wanting to come up with a fraction that I can put here, here, and here to make all of these true. I want all of the numbers over here to be less, or sorry, not less, greater. I was looking down here, greater. So this side has to be greater than 3/4. This side has to be greater than 2. This side has to be greater than 7/5. Okay, so if I were to look at this, I know that if it would be greater than any of these numbers, this 2 times 2, I would have to have it be bigger than 2/2. Because if I made this as a fraction of 2/2, then that means this is going to be equal and it's going to be 1. So remember, I want each of these sides to be greater than, okay? So I know it can't be that, but one thing I do need to look at, because I know this is less than 1 right here, 3/4, so I'm okay with that. This is 2. This one, if I were to rewrite this 7 1/5, that's 1 2/5. So no matter what, I need to make this 1 2/5 greater than this. Same thing as here. So what I'm actually going to do is, because I don't want to do 2/2, and that's 1, so I need to have this one be greater than 1 as well. So I'm going to have to make this, oh, let's see here. If this is 1 2/5, I want to make sure that this one's going to be bigger. So let's go ahead and make this 5/2, okay? So 5/2 is actually going to be, when I do 5 divided by 2, that's going to be 2.5. So I've made it 2.5. Each of these I've multiplied by 2.5. Oops, I was writing 2.5, not 5/2. That no matter what, each of these numbers are going to be greater, okay? So I could have done, if I really wanted to, I could have done 4/2 probably, and made it as 2, but then we would have the issue of being able to check to make sure that it is. So we want to make sure that when we multiply a fraction greater than 1, we have to make the product larger than the other factor. So we had to make sure that when we compared these and looked at these, we needed to make sure that my fraction that I multiplied it by is bigger than that greater factor, and that greater one is 1 2/5. Now this one, it's the opposite way. I want to make it less than, okay? Because all of these are less than. And if I look at this, well, I made 5 halves, and I need to make it less than. And so what I need to do is I need to actually make this not be a 1. So I'm actually going to multiply each of these by 1/2, because I know that when I come here and I want to take 3/4 by 1/2, it's going to be smaller. 2 times 1/2, it's going to be smaller. 7/5 times 1/2, it's going to be smaller. So when I multiply by a fraction that's less than 1, the product is going to be less than that other factor.